Hey, Math Wonders. I know you're missing school big time. You wish you could be here with me, but we got to do what we got to do, don't we? So today we are going to take notes on section 5.4. We're going to continue with some geometric sequences. We're going to look at sequences that involve percent increase or percent decrease, and some application problems maybe of some sequences. So let me set up. Bang. See if I can get my camera going here. Uh-oh, almost fell over, but no. Saved. Let's see. That seems pretty good, but I wish it was a little bit different. Let me do that. That's pretty good. All right, here we go. So we are doing section 5.4. I still feel like it should be a little bigger, maybe. I don't know. How's that, you guys? Is that all right? All right. So we are going to write equations for geometric sequences. You already know how to do that. It's a little different when you have a percent increase or decrease. So we're going to talk about that, and we're going to look at maybe some more difficult problems. We'll see what you think. There's a great challenging problem at the end. All right, so to write an explicit equation for a geometric sequence where the increase or decrease is by a percent, you do this. You know, often, well, here we go. For percent increase, the multiplier, right? The multiplier is another name for the common ratio. The multiplier is 1 plus the percent. So if you had an increase of 7%, for instance, my daughter's college generally increases their tuition 7% each year, then you would have a multiplier of 1 plus 0.07, right, which is 7%. Or that would be 1.07 would be your multiplier, your common ratio. If we had a decrease by a percent, then the multiplier is 1 minus the percent. This is the one students mess up occasionally. So a decrease of 12% would have a multiplier of 1 minus 0.12, or 0.88. A multiplier of 0.88 means there was a 12% decrease. Right? It's kind of like you multiply by the amount you're keeping. So if you're decreasing by 12%, you're keeping 88%. So we're going to practice a few of these real quick. This will not be hard, and I probably made too many here. But let's have a starting amount of 100, 200, 300, 400, 500. And our equation is always going to be T of n equals, so let's write that down. What the heck? All right. And let's say we have an 18% increase, maybe a 24% decrease, maybe a 6.5% increase. We'll save the last two. Maybe they'll be harder. So my question is, what is the growth multiplier? Or that's another name for the common ratio. What is the common ratio? Well, if there's an 18% increase, then the common ratio is 1 plus 18%. Hopefully you got 1.18. If there's a 24% decrease, do you know what it would be? A 24% decrease would be 0.76. Right? That's 1 minus 0.24. Here's a tricky one maybe. How about a 6.5% increase? So 6.5% as a decimal is 0.065. So the common ratio would be 1.065. All right, how about if we had something like an 80% decrease? So what would the common ratio be? Well, it'd be 1 minus 80%, which is 0.20, or you could use 0.2. How about a 2% decrease? That would be, let's see, 1 minus 2%, right? 2% is 0.02, so that would be 0.98, right? If you're decreasing by 2%, then you're keeping 98%. And then hopefully the equation after yesterday's homework is quite easy for you. So the equation here would be the starting amount. That would be like the zero term times the multiplier, which is 1.18 to the n. This would be 200, 300, 400, 500. And it would be 200 times the common ratio, which is 0.76 to the n. Are you getting these? 300 times the common ratio, which is 1.065 to the n. We would have 400, the starting amount, times the common ratio, which is 0.2 to the n. And last up, we would have the starting amount, 500, times the common ratio, which is 0.98 to the n. All right, so now that we've practiced those a little bit, let's see what we can do on some of these tables. All right, so you have a sequence here, right? N is the term number, and T of n is the term. And if I want to write an explicit equation, well, the first thing I got to know is what's the common ratio. And right, I get the common ratio by taking any term and I divide it by the previous term. And that would be 1.25. So you guys, I have two choices now. I could just go ahead and write the explicit equation. It would be the first term times 1.25 to the n minus 1. Or I could work my way backwards, and I could figure out the zero term. The zero term is the first term divided by the common ratio. So 2,000 divided by 1.25, that is 1,600. And it would be 1,600 times 1.25 to the n, right? Since I went backwards one term, my exponent has to go up one spot. So n minus 1 up one spot is n. Either one of those is good. About the second one, what's the common ratio? So I would divide 103.68 by 72, and I would find out that that is 1.44. So 1.44 is the common ratio. Should we just use the first term? 72 times 1.44 to the n minus 1? Or should we work our way backwards to the zero term? 72 divided by 1.44 would get me the zero term, and that's 50. And so I could write T of n equals 50 times 1.44 to the n. All right, I won't do that anymore, but either one is really fine. No, it figures this one we actually have the zero term. So I'll just use the zero term. All I need is the common ratio. I'm going to use these guys to get the common ratio. They seem like easier numbers to use. And it looks like the common ratio equals 1,600 divided by 2,000. I believe that is 0.8. And so my formula would be T of n equals 3,906.25 times 0.8 to the n, right? I hope those are not a big deal for you at this point. Let's go over a couple application problems, because percents often lead to application problems. And the topic today is percents, increase or decrease. So here I have a Honda Civic. This is actually true, except it was a Toyota Corolla. that I bought in 2016 for $18,900. So that's like my zero term, right? The zero term, the starting amount, $18,900. But each year the car decreases in value by 14%. So my common ratio is it's going down by 14%. That would be 1 minus 0.14, or 0.86 is my common ratio. Oh, I went right through it. Sorry about that. 0.86. So what would my formula be to calculate the value of the car after each year? Well, my formula, I guess, would be T of n equals the zero term, or the starting amount, times the common ratio to the n. What does n represent in this formula? It represents how many years old the car is. All right? Each term number is another year. So when n is 1, the car is 1 year old, and that would be my first term. And when n is 2, the car is 2 years old. That would be my second term in this sequence. And I think we want to know what is the value of the car today. So in 2020, well, the car is 4 years old. So I'd be putting 4 in for n. I want to know what T of 4 is. And it's 18,900 times 0.86 to the 4th, which is approximately $10,338.45. Now, see if you can get this one. How much will it be worth when it's 10 years old? And then, pause real quick and then turn it back on and see if you got it right. So what we're calculating here is T of 10. Right? We're putting 10 in for n. Or this is the 10th value, or the 10th value in the sequence. That would be 18,900 times 0.86 to the 10th power, which is approximately, because I'm rounding to the nearest penny, that is approximately $4,182.60. Did you get that? All right, I've got 2 great examples on the back. The first one is a story problem. Sorry about that, but I love the story problem. Wrote it myself, perhaps. All right, so example 3 says, thanks to millions of teens around the world seeking to be just like their math teachers, industry analysts predict that sales of the new PiPhone will skyrocket. Look, I found this article online. PiPhones sweep the nation. Teenagers and Hollywood celebrities are expected to flock to an exclusive shop in Beverly Hills, California today, clamoring to pick up the new PiPhone. The PiPhone release began last week when the store pre-sold 100 phones. The store expects to sell an average of 15% more this week and each week thereafter. I plan to stand in line all night, said Nellie Hillman. As soon as I own one, I'll be cooler than everyone else. The article went on, but I stopped there because you get the idea, right? So this article provides a situation for the number of PiPhones the store expects to sell. They started by pre-selling 100 PiPhones. So, right, you should recognize that as that's our starting amount. And our starting amount is our zero term. And our zero term is 100. Right? When we start graphing these things, our zero term would be our y-intercept, right? The starting amount is the y-intercept, or when x equals 0. Write an explicit equation for the situation, then use it to predict the number sold during the 10th week. All right, so I have the zero term, but I need, if I'm going to write an equation here, I need the common ratio. Now, what is the common ratio? They told me that they expect sales to go up 15% more each week. So an increase of 15% would be a common ratio of 1 point, did you get it? Did you get it? 1.5, right? So my equation would be, and you know, technically these application problems, you don't have to write them as t of n's. You could use y notation, or you could use function notation, but not use t. What are these, pi phones? Let's use p for the number of pi phones. Let's go p of n equals 100 times 1.15 to the n. That is the equation for this situation. And if I want to know how many they're going to sell on the 10th week, because in this situation, n represents the week number. All right? This is 100 is after 0 weeks. It's the starting amount. But what about the 10th week? So this would be 100 times 1.15 to the 10th, right? Or approximately, it's 404.5, so I guess I'll round up to 406. So they will sell approximately 406 phones during week number 10. Let me see. The store needs to know how many phones to order for the last week of the year. How many Pi phones should the store predict it will sell during the 52nd week, right? So a year has 52 weeks. We want to know how many phones to order for the last week. So that just means we want to figure out P of 52. That would be 100 times 1.15 to the 52nd. So, by the way, I wanted to make sure you know, you could just type that exact thing into your calculator, right? Let me do it right here. So that would be 100 times 1.15 to the 52nd. Check out this number. Oh, baby. That means approximately, let's round it to the nearest whole number. So let's make that a 4. And this would be 143,314 Pi phones. You got it. All right. One more thing on this one, and we'll get to the challenge problem. Jack is in charge of ordering stock for the store. He wants to use a recursive formula to show the predicted sales of Pi phones for each week of the year. What is the recursive formula? So I like to put my little bracket down. And to get the recursive formula, I need, I need the first term. Oops, I'm using P. I need the first term. And then I need to know how to get from P of n minus 1 from any previous term to the next term. And this is a geometric one, so I'll be multiplying by something. All right, so the first term, I guess I didn't calculate the first term, but it would be, all right, let's see, it would be 100 times 1.15 to the first power. Well, that's just 115. The first term is 115. And any term, right, that's what that stands for, any term is equal to the previous term times 1.15. There's our recursive formulas are easy, aren't they? They're not very helpful, but they're easy. All right, last example. This is an awesome example. If you can get this on your own, very impressive. So I want to find the explicit equation for this sequence. And if I want to find the explicit equation, of course, the first thing I need to know is the common ratio. But the problem is, I don't know any term and its previous term to calculate it. How am I going to calculate it? You ought to pause it and see if you can figure this out for a couple minutes on your own. But if not, it's okay. I'm going to show you. So here's how you would do it. Look at this. Here's what I do know. I know that if I multiply 50 by the common ratio, I'll call the common ratio x. If I multiply 50 by x, I get the next term. And then if I multiply that by x, I get the next term, which is 72. So that means 50 times x equals 72. Or 50x squared equals 72. And I can actually solve this for x, and I'll know what the common ratio is. I would divide both sides by 50. Well, 72 divided by 50 is 1.44. And then I want to get rid of the square, so I would take the square root of both sides, and I would get 1.2. The common ratio is 1.2. And I could go right to my formula now by using the first term if I wanted. I could say T of n equals 50 times 1.2 to the n minus 1. Or I could work my way back to 0. This would be 50 divided by 1.2, right? The first term divided by 1, the common ratio. That's how you get the 0 term. That turns out to be a yucky number, though. It's like 41.6 repeating, which is not a great number to put here, which is why sometimes we use the first term. But I could put it if you really want. That is 41 2/3 times 1.2 to the n. All right, that's it, you guys. Good luck. I will talk to you tomorrow on Schoology, I suppose, maybe. See ya.